Good afternoon. Welcome to my Game Boy programming stream. On the last stream, what did we do? We drew some more object art. We improved terrain tiles, and we started adding Game Boy Color support. Although right now the palettes are all only grayscale, so so it still kind of looks like a Game Boy game instead of Game Boy Color. What I want to do this stream is to expand on that Game Boy Color support to add more palettes so it actually looks like a Game Boy Color game. And then I'm really hoping to draw the sprite for the player character and let you use the D-pad to move him around. So, uh, let's do a few announcements. First of all, just something completely random. Over the past couple of weeks, I started experimenting with Game Boy Advance programming for the first time, and it's been going really well. And I have to be over here. And it's been going really fast. Like it took me like 30 minutes to get the terrain loading going. That it took me like a couple of hours on Game Boy. So C is a more productive language than assembly. So this has been fun. I don't know if I'm going to do streams of Game Boy Advance programming, but that's just something fun that I've been doing on the side. Um, Recently on YouTube, I got a comment that was a really good idea, which was I should actually introduce myself. Uh, this is my fifth stream, and I haven't really properly introduced myself, so it would probably be a good idea to say who I am. So let me clear this out of the way a little bit. So, hello, I am Donald. I am a programmer. I'm mostly professionally an iOS programmer, but as a hobby, I've enjoyed doing game programming. And For like my whole life, I've really loved the Game Boy. And a couple of years ago, I started getting into Game Boy homebrew programming. Um, I've been doing a mix of C programming and assembly programming on the Game Boy, and recently I've been wanting to get back to assembly programming on the Game Boy and to try porting an old game of mine uh, to the Game Boy. So that's what this series of videos is about. Um, it was also suggested that I show off what my tool setup is. The programs that I'm using, how they link together, how they work in my environment and tools. So let's go here and talk about that. So the editor that I'm using is Visual Studio Code, which is a free version of Visual Studio. If you want to try it out, it doesn't cost anything. It's a free download. I am using an extension that I made for it. Let me see if I can load up the extension. Uh, I am using an extension that I made for it, which is called RGBDS Z80. Um, I named this before there was kind of a community discussion about the processor in the Game Boy, and it was decided that the Game Boy didn't actually have a Z80. It's referred to as an SM83, but I named it, but I already called this RGBDS Z80. So this is an extension that I developed for Visual Studio Code that helps assist in Game Boy assembly programming. Uh, the most important thing that it does is it can extract your documentation comments on symbols to make it so that if you, let's find a routine here. So that if you write comments before a symbol declaration, then when you mouse over the symbol declaration later, you get a popover. This is so like documentation is always a good idea when programming in general, but in assembly, I find it to be super critical because you have like register management to deal with. And so I like documenting my symbols to put the registers I'm using and what the return values are going to be in registers so I know why I need to preserve, why I need to pass, things like that. The extension does a whole lot of other things too, but like that documentation extraction is the thing that I just find most useful. The assembler that I'm using is called RGBDS. It is the most popular assembler for Game Boy. It's been around for about 20 years, but it's had a lot of activity in the last couple of years as the community has really kind of picked it up and has been moving forward with it. And my Visual Studio Code extension is specifically designed for this assembler. To compile the game, I'm just using a makefile. And it's not that big of a makefile, and there's nothing very fancy going on about it. But I'm using make as the compiling tool. I am drawing the art in Aseprite, which I think is my very most favorite program for pixel art. I love it so much, I ended up buying it twice. I once bought it on, I forget where I first bought it, but I didn't like, but Aseprite updates relatively frequently, and I didn't like the update mechanism wherever I bought it before. So later I ended up just buying it again on Steam because Steam's auto updates are really convenient. I draw these tiles as just regular PNGs that go into just an image folder here, and then the makefile recognizes the PNGs and generates these bin files out of it, which then get linked into the program. So it's very easy for me to just like draw on the art. Try and make a smiley face here. Okay, that's a smiley face. And then I can just build, and the makefile recognizes that the PNG has changed. And so then I can reload the program, and there's my changes. So like it turns my art into source code files the same as my regular text-based source code files. And I am using SameBoy as my emulator. If I were programming on Windows, I would probably be using BGB, but I'm on an Apple Silicon M1 ARM Mac, and it's 64-bit only, and it's a different architecture than Intel. When I had an Intel Mac that could run 32-bit apps, I used to run BGB through Wine, but right now I'm just using SameBoy. I think that's about it for the setup. Oh, to play on actual hardware, I have an EverDrive X7, and so I can just take my ROM, put it onto a micro SD card, load that into the EverDrive, and then I can play on actual hardware. And so that's the setup that I'm using. So the first thing that I'm going to be doing in this stream is I'm going to be changing the barrier art because, like the barrier right here. Because, let me cut back to the camera intro because I've got an image here. Because speaking of real hardware, I found that the barrier image isn't that great on real hardware. The contrast isn't good enough, and it looks very, very similar to one of the gems. This is why it's important to test on real hardware, and the original Game Boy screen really isn't that good. And so I had tried to design the barrier image, which is in the lower right-hand corner, of that circle, the barrier image. I tried to make it have good contrast from the square gem. And when looking at it in an emulator, it looked okay. If you look at the screenshot on in the screenshot, it looks kind of okay, but on actual hardware, the contrast wasn't where I wanted. So the very first thing I'm going to do is I'm going to be changing that barrier image. So let's toggle back to the project and do this. So the thing that I was thinking that I'm going to do is I'm just going to cut into the corners a bit. I'm going to make it a little bit more like diamond shaped, which will make its shape a little bit more similar to this, but the color of this is just wildly different from the barrier. And so even if they have a similar shape, the fact that the color is completely different should still make it plenty legible on the original Game Boy. So let's just do that. I want to do something like this. I want to make it Yeah, I kind of want to make these little lines look like little pieces that are sticking out a bit, and then I want to have a little bit of an inset corner. Hmm. Think like that. Yeah. Mm. Yeah, I think that's right. Oh, this one's gonna be easy. Just there's something not right here. This is oh, there's quite a few things not right here. What's going on here? 1, 2, 3. 1, 2, 3, and then you know, I'm gonna do something a little bit different. I'm just gonna erase everything here and then just redraw what I want. Yeah, just erase a whole bunch of stuff. And go away. Okay. Let's bring up the symmetry guides. Might help me out. Turn off the grid. It's throwing me off a bit. All right, grab the symmetry guide. Oh, I see. Maybe this barrier wasn't ever symmetrical to begin with. That could be a problem. Okay, okay. Oh, whoops. That's not what I want. I want this. There. All right. And then what do I want to do here? I just want to go like that. Like that shape. Or do I want something a little bit more squared off? Let's try a little bit more squared off to start. Okay. Now I'm not going to want the symmetry guide for the rest of this. Because I want to fill some of these in with... Actually, let's fill this in dark gray. Fill these in black. And fill this in dark. Let's do a dark gray line here. Light gray here. There. How distinct does this look? Let's see. Well, I don't think that looks quite like anything else. Let's see how it looks on a Game Boy. Oh, sorry, bumped the microphone there. check that. Go ahead and check that micro SD card anytime you want. There we go. Let's leave this plugged in here for now. Okay, let's cut to the camera view because I'm going to want to show it to all of you once it's up and running. All right, let's see here. That's the wrong that's the wrong ROM. That is the old Game Boy version. I have like both a GB file and a GBC file in there. Because I made it a GBC file last stream. Okay. Let's load this up again. There we go. All right. Oh, that's the volume down. Let me adjust the contrast here. Let's try dialing the contrast up a bit. It is lighter. Yeah, I think this is I think this works a lot better. I don't think anybody's going to confuse that for the square gem or anything else right now. It's the same shape as the button, but it's also clearly not the button. So I think this will work fine. And that's why you test on real hardware. I think that's going to finish that task. That was fast. All right. Okay, so next is Game Boy Color palettes. So last stream we added basic Game Boy Color support. But you can see the only palette right now is grayscale. So it looks like a Game Boy game. So what we're going to do is so on Game Boy Color you can have 8 background palettes and 8 object palettes. What is going on with object palettes there? That's completely wrong. Oh, it's because I just copied this over. All right. So, I think the first thing that I want to do is I actually want to define a macro to let me define colors in a friendlier way than this. What I did last stream in order to define the colors was I was actually like punching in bits manually into the calculator. I think I want a macro to define colors. So eventually I'm going to put it in a better place than this, but for now I'm just going to define it here. What's the new syntax for macros? The syntax for macros changed a couple of months ago. Okay. So the colors the colors on Game Boy Color are defined as a 15-bit well, I think it's like blue, green, red. I think blue is the most significant bits. So what I'm going to do is I'm going to have a macro called RGB555, and you're going to pass numbers ranging from 0 to 31 for each of red, green, and blue. And then it's going to make a number literal that can go in a spot like this. So every Game Boy Color palette has 4 colors in it, and each color is 2 bytes because it's 15-bit color. So you use 5 bits for red, 5 bits for green, 5 bits for blue, and then the last bit is just 0. It's not used for anything. Um, so that's 0. Okay, so macros. How do I do arguments in macros? Mm-hmm. Okay. Come on, give me a /1 here. Okay, okay, there we go. Okay. Am I going to be able to use this the way I want? Let's see. Let's give this a shot. All right, so this is going to be oops, /1. Can I do a bitwise OR operator like this? Or is it going to be, or is there a pipe? Yeah, cool, cool, cool. And I think red is the least significant bit. So I'm going to do the first argument is red, second argument is green, third argument is blue. But I think red is the least significant bit, so I'm not going to bit shift that. Can I do this? Is this valid syntax? Does this work? I have no clue if any of this is valid or if I need all of these parentheses. Let's just give it a shot. All right, so the first color is white, so let's try. Is that valid? That's not valid at all, is it? No, that's not valid. Hmm. Hmm. Is there a way to do what I want? Can I treat a macro like a function? Like this? There's no way this works, is there? I can't do any of this, can I? Yeah, this isn't. I might not be able to do the macro the way I want. Hmm. If anybody in the chat knows RGBDS macros and if I can do what I want to do, please feel free to share. Hmm. Hmm. All right, where would I look to do something like this? The constants. Yeah, I mean, I suppose I could ignore the fanciness and just do something like this. Like, that's valid syntax. It's not as nice as I want, but I should be able to. Oh, I'm already in Visual Studio Code, right? So I should be able to just reload and it should be white. All right. And then let's see here. This should now be purple. The color white should now be purple in the first palette. And I think every tile right now is just reading from the first palette. So. Oh, no, no, no. This is blue that I'm taking out. So if it's red and green, if it's what I think is red and green, then it should be yellow. So let's see if white turns into yellow. Yeah. Well, it's more of an orange. That's interesting. Wonder if this is doing color correction. All right. All right. So let's define. I think the first one I'm going to want to define is the terrain color. And I think I'm going to change the way that I'm doing this. So let's do palette 0 terrain. And I'm going to do a multi-line declaration since I'm going to be doing this expansion here. Wish I could do something like this, but I don't know. Okay. So what I'm going to do is the brightest color is going to be white. The terrain, let me go back here real quick. The you can see from the Game Boy Advance version of the game, and it's similar to what I did on the old iPhone version of the game. I had the terrain be blue, just because blue is a good contrasting color against all the gem colors I used and the hero character and the other objects. So I'm going to do blue terrain here too. Um, but I want the brightest color to just be pure white. And the reason for that is going to be because I'm going to be having gems sitting on top of that, and they're each going to have their own palette, and I'm just going to have white be the common color across all of the palettes. All right. So let's do, all right, so for black, let's do, I don't know, let's try and have a highlight color be the brightest color, the brightest actual color. Uh, let's do, let's try, all right, let's do set blue to 25 and 15. I should really be doing this in an actual color picker or something instead of trying to just make up colors, but all right, and then the highlight color should be shifted slightly towards yellow, so I'm going to put a little bit more green in here. So let's do 25 and 20, and then down here, let's have this be just 10 and 10s to shift a little bit more towards blue. All right. Let's see if this looks at all decent. I mean, I definitely want to adjust it more, but something I didn't see at all before I typed it in, that's not that bad. I could use a little bit more saturation on the dark blue. So how do I do that? Let's maybe dial that up to about 20. Let's kick that down to 8. It might be a little bit too saturated and a little bit too bright. And let's make the darkest blue even darker. So let's bring that down to 3, 3, 8. Also, another question for chat. If anybody knows how to skip the intro on Same Boy, the Game Boy intro is nice and fast, but the Game Boy Color intro takes a moment to load. So if anybody knows a way to turn that intro off, that would be convenient. Yeah, that's not so bad. All right, now let's pull down the brighter color a bit. Let's bring this down to like 15. Was I really doing 25, 25? That's too much. Let's do that. Ooh. Ooh. I like that. Okay. Yeah, I like that. That's a good first palette. Second palette, I want to do the red gem. So here's what I'm going to do. I'm going to create a blank palette there. I'm going to temporarily comment this palette out. So that I'm removing the first palette, and then I'm going to create a new palette, and I added an extra blank row so that I still have the right number of palettes since I got rid of that one. So I'm going to define what's actually going to be palette 1, and we're going to do the red gem. The red gem is the red triangle gem. All of these palettes are going to have white at the top. All right, so now I want the shadow colors to be shifting towards blue. So I'm going to use 8 here, but I'm going to punch up the blue on the black shade here a little bit to make it a little bit more of a purple. So it's just so I'm trying to hue shift the colors as I go, just because that makes for more visually interesting palettes. You try to shift the highlights more towards yellow and the shadows more towards blue or purple. And that just tends to make more aesthetically pleasing um, palettes. So let's see here. Let's just reuse the values from up here. Let's do 25 and 20 and 15. That's not so good. Yeah, let's move on. All right, and then 18, 8, and then let's draw up that color just a little bit. That's not same boy. All right. That's nowhere close to the colors I want. All right, let's make the dark red a lot richer of a red. Bring this down to 5. It's down to 10. Let's punch up the actual amount of red. As a background tile, that's way too red, but on the actual red gem, looks pretty good. All right, now this more kind of goldenrod color, I want to bring up more towards a good and proper orange. So let's actually make it orange. Or that wouldn't make it orange. This would make it more yellow, so. See, like drawing an Aseprite is wonderful for productivity. The alternative of using a proper art program would be like typing in your sprites, and that's obviously not very productive. And now we're seeing kind of like what that's like when I'm working on these color palettes here, because this is a very manual text-based process. Uh, like I'd probably be so much more productive at this if I was actually just doing this in Aseprite or something, and then copying the values over. But 15-bit color introduces a little bit of a challenge when converting, because it's only every X number of RGB values is valid, and so you'd be rounding. Let's bring this up. How do I get the orange that I want? Well, that's starting to get a little better. Is the answer to go all the way down here with this? Maybe the answer is to really bring down the blue in it. Ah, there we go. I think I might be happy with that. It's this gem that we're coloring right now. I think that might be what I want. I think that'll do. And for now, let's actually take a little bit of a break from creating palettes. And let's start writing some assembly code to actually load these palettes separately. So there's going to be a good bit of work for that. How long have I been streaming? Only about half an hour. Okay, we're doing fine. So, how are we going to do these palettes? Because, okay, so let's go to the Pandocs. On Game Boy Color, so I think there's I think there's like a separate bank for tile memory that represents the Game Boy Color attributes where you specify the palette, and I think there's also like optional flipping flags that you can do. And we're not going to be able to take advantage of the flipping flags because we got to maintain compatibility with Game Boy, and if we wanted to be taking advantage of those flags on Game Boy, we'd need to have equivalent pre-flip tiles in this. But we are interested in the palette support. Oh, background map attributes, color Game Boy mode only. I didn't do so much research before this stream, so we're going to be researching live. Color Game Boy mode, an additional store in VRAM bank 1. Yep, okay, so it's just in another bank. So it's like it's overlaid on top of the regular background tile map in video memory. It's in a separate bank. How do I toggle that bank? How do I write to that bank? I don't know. I'll figure it out later. So there's a priority bit. Flip, not used. Tile VRAM bank number. That's another thing that I can't take advantage of. On Game Boy Color, there's an additional bank of tile memory, and that just lets you have way more tiles on Game Boy Color. Not going to use them on a universal cartridge, and I don't need them either because I don't have all that many. Here it is. The low 3 bits is used to select the background palette number. Okay, so okay. So this exists just at the same address as the tile entry, but how do I select this bank? How do I select the bank? Tile map contains the one by index of the tiles. Tiles are obtained using tile data table using either of the two addressing modes, which can be selected via LCPC register. An additional is stored in VRAM bank 1. How do I get access to VRAM bank 1? Does this show VRAM bank 1? Window enable, blah, 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 blah. Palettes. LCD color palettes. All right, so the issue is I've seen the documentation for where I'm going to be writing palettes, and it's just overlaid on top of the regular tile map data. But I need to figure out it's the attributes for a tile map entry are at the same memory address as the tile index of the tile map entry. And right now I can write the index, which is how I load the map. Now I need to figure out how to toggle into the other video bank where I can write the attributes to. So where is that? Oh, this is a handy reference. I should remember this. This is a handy reference. It's handy to know exactly how much time you have for vertical blink. It's not a lot. And as an aside, I mentioned at the beginning of the stream, I've been starting to play with Game Boy Advance programming. One of the things that's so convenient. Okay, so vertical blank is the period of time in which you can safely modify a graphics memory. And on the Game Boy, vertical blank lasts for about, I think it's about 5% of the total frame time. Is how much time you can spend in the longest blanking period safely writing to video memory. You can also safely write during horizontal blank, but those are incredibly short. The largest contiguous block of time in which you can safely write to video memory is during vertical blank. And on Game Boy Advance, that still applies, but on Game Boy Advance, it goes from like 5% up to 15%, I think it is. And then the Game Boy Advance is also just much faster in general, so it's so much easier to budget time on the Game Boy Advance. Oh, look at this. Color Game Boy registers. That looks like what I want. VRAM DMA. Transfer times VRAM banks. VRAM banks. Change VRAM all of them. I think this is it. I think this is what I want. There we go. Prepare speed switch. Game Boy Color, and when you're running in Game Boy Color mode, you can toggle a bit here and it'll overclock the Game Boy Color CPU. It'll actually run at twice the speed. The thing that's kind of funny from everything I understand. So the original Game Boy, the original Game Boy took 4 AA batteries, and then the Game Boy Pocket took 2 AAA batteries, and then the Game Boy Color went back up to 2 AA batteries. For the Game Boy Pocket, because it jumped down to those 2 smaller batteries, you might be tempted to think that it's like, oh, they made the system so much more efficient, it needs less batteries. As far as I know, no, that's absolutely not true. It's like literally the same hardware in it. They just put less battery in it, and so the Game Boy Pocket just has a much shorter battery life. And Game Boy Color, it's like you can double the clock speed of the Game Boy Color, so you might think, oh, did they make the CPU a lot more efficient so that they can afford to make it double the speed? And again, from what I understand, nah, they just let you double the clock rate and pay the price in battery life. So, and I actually may end up dealing with this because, like I said in a few minutes ago, vertical blank time is so short on the Game Boy. And on Game Boy Color, I have these large palettes I need to copy over every now and then. And I might just take an easy mode way out and just double the speed of the Game Boy Color to give me plenty enough time to just naively copy those palettes over. Because I want to get this game done quickly, because there's a timeline on it. So anyway, FF4F. Do I have a register defined for that? FF4F? Hey, I do. Oh, wow, I documented it and everything. I am awesome. Select bank 1 or clear to select bank 2 when bank 1 is selected. Is this not the register I want? Split like 8,979. Wait. Oh, okay. So when I flip the bit, I might have misdocumented this a bit. Oh no, I didn't misdocument it. I just didn't read the second half of the sentence I wrote months ago. All right, when bank 1 is selected, the second set of 192 tiles will be available and attributes can be written to the background maps. This part might not be quite right, but okay. So what I want to do So when loading a tile into the background map, the first thing that I want to do is to write the tile to the index for which this bit will need to be 0. Then I'll flip this bit to 1, and then I will write the index of the palette to the exact same tile address. So I'm going to be wanting to do those two things on top of each other. So generate vertex map I don't want. It's going to be somewhere where I'm writing graphics tiles. Set vertex map entries to 1. It's not what I need. Generate vertex map. Get vertex map value. Map random. Populate graphics tiles. This is where I'm going to be doing something. Based on the values of the vertex map. Okay, so in this routine, so I'm going to be having the terrain. I'm going to be having the terrain palette be palette 0. So no matter what in this, and this one doesn't draw map objects. This only draws terrain tiles. So no matter what, every time this routine happens on Game Boy Color, it wants to set the blue palette. So it just wants to set the palette to 0. So. Da, 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 da. All right. So this is loading the bits. Add 16 to tile. Okay. So, right here, the value of background map plus plus e. Okay. I think we're gonna do this up here. I'm gonna set the palette first. All right. So Game Boy Color work. And again, this is part of the reason I might just double the clock rate on Game Boy Color. It's just because I'm going to be adding little pieces of Game Boy Color code everywhere. Okay, so I'm going to load the model, the Game Boy model. Ooh, let's plug my computer back into power again. I'm like, why is my battery life going down? All right, all right, okay, all right. Bit one, bit GB model. So what is it? Is it the bit routine set 0? Yeah. So this is the test routine. Um, what was the bit called again? Bit GB model color Game Boy. Do I need to? Okay, yeah. That's why I wasn't showing up in autocomplete. I need to include it. Okay, and so the bit routine will set, or the bit instruction sets Z if bit is 0. So if it is 0, then we're not on Game Boy. Or we're not on Game Boy Color. I just want to check something really quick here. I know it'll set it to 0 if the value is 0, but I want to make sure it'll set it to 1 if the value is 1. Like, I want to make sure it specifically sets the value of the Z flag to the value of that bit. I'm just going to assume it does what I want it to. Uh, this assembly logic, there's so many, like, is it 0 for affirmative, 0 for negative? It's this is going to be, the bit is going to be 1 if we're on a Game Boy Color or Game Boy Advance. So we will set the 0 flag if we're just on a regular Game Boy, in which case we don't want to run the Game Boy Color logic. Okay. Can I just set a bit on... Ooh. Hmm. 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 Let's do this easy mode. Okay. R CGB VRAM being select. Okay. So I want to set the bit first to 1, right? Yeah. Are we on Game Boy Color? Switch to VRAM Bank 1 to set palette. All right, and then here we're gonna reset the bit. Switch back to VRAM Bank 0 to set file index. Okay. Then I think I can just load 0 into the register. Let's check that video memory again. Because I don't care about this, or this, or this, or this, or this, because that's saying, yeah. Yeah, so it's literally, yeah, so all these other bits are just going to be completely unused by this game. So all that I have to do is just put the actual palette number into the low bits. That's annoying. HL has my current background map tile address, and I just used it to do all this. So I need oh, I'm so ashamed of myself. Can I? There's no load. Yeah, I have to. Okay, so first set A to 0, then load the address. It's shameful, I'm telling you. All right. VRM Bank 1 to set palette. Load palette 0 into the address of the background map. Then we're going to switch back to VRAM Bank 0 to set the tile index. And at the end of this block, we're the same as we were before we started. Okay, so that should have been an awful lot of work in order to make absolutely no visual difference. Let's see. Good. All right, now we should be able to see a visual difference if I change this to 1. Because it's not in this file. Because I still have the red palette here, and it's now set as palette 1. And I think I'm loading the whole palette, so I should now see a red palette. This is not a red palette. All right, so first suspicion, let's check out. First suspicion, let's check out palette memory. Is there a viewer for palette memory? Yeah, show viewer and viewer. Have I loaded the palette? I have loaded the palette. Okay, so it's not a problem with palette loading. So for some reason, I'm not correctly setting palette 1 here. Why am I not saying palette 1 here? Hmm. Hmm. It doesn't break horribly on the Game Boy, does it? It's like if I'm actually... Yeah, I don't see any problem with that. Push DE, pop DE, pop HL. All right, what's something that I could do? Just to make sure that I'm correctly entering this block. All right, so on Game Boy Color now, it should completely deadlock when loading the map. Okay, we're correctly entering this block on Game... And in fact, let's make sure we're not entering this block on Game Boy. Okay, so that's not the problem. We are entering this block. All right, push HL and DE to give us the scratch space to work with. We copy H into D, we copy L into E, HL, DE, so that should be right. DE now has the background map address. We should be switching FF4F, loading FF4F into HL. And then we're setting a bit to set the bit U3 to 1. Can I watch FF4F? Okay. What is that call? What? Where am I? That looks more familiar. All right, what is step? Step. It's interesting that I did that. I don't know. No, not echo. What do I want to do? Do I want to print? Do I want to examine? Okay. What's the thing to just... Can I do this? I don't think that's what I want. Maybe it is. I don't know. That's weird. What's going on here? Voting 8? Wait, what is HL right now? What is that? That's not FF4F. What is this code? What is this code? Wait, the address is less than 100. I don't know what this... Oh. We're in the boot ROM, aren't we? That's what the problem is. Yeah, we're in the boot ROM. Like the Game Boy Color itself shifts the palette around or something, I think. Oh, okay, 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 okay. Think we're doing different now? I think? I don't know. I'm confused. Oh, there. Okay, okay, okay. All right, now we're in my code. Mhm. Okay, so we just set. Okay, so it's trying to set. So what line is it now? Load D. All right. So what is the value right now? Is this what the value currently is? Why is it giving me a 16-bit value there? I don't understand that. All right, well, it says that the current value is FE, which seems a little weird to me. Every bit is set except the least significant bit. That seems weird. Oh, wait. There's only a single bit that we care about on here. This is the background map attributes for... Oh, okay, okay, okay. There's only the single bit that we care about here, and it's the least significant bit. And right now, the least significant bit is 0? This here should equal 0. No. Okay, I get what I'm doing wrong. I get what I'm doing wrong. Okay. All right, so the problem is I'm reading this table here, which is the actual set of bits for writing into the background palette map, not for writing to this register. For this register, all I have to do is set the register to 1, not set a specific bit, just set the value of the register to 1 in order to select VRAM Bank 1. This is about setting a bit in a Game Boy Color background map attribute. So it's just this bit is for something else. So what do I want to do? Oh, I could just load an N8 into here. Boy, that took a long time. All right, so now, help. All right, unwatch. Yeah, just unwatch everything. Okay. Red palette. And blue palette. Okay. Man, little bugs like that are annoying. Gray palette. Okay. What does command 0 do? Yeah. Apparently I'm saving a state when I accidentally did command 0. Okay. 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 So now what I want to do is that game object definitions need to be associated with a palette. So the red gem needs to not only point at this tile, it also needs to point at palette 1. Then I think this one will point at palette 2, so on and so forth. So I need to change my definition of map objects to include the palette index. Kind of wonder if I'm going to want to extract that into a method or macro or something. I don't know. Let's ignore it for now. Let's copy and paste code later. Let's just get this over with. All right, map objects. So it's map objects in here. Map erase tile. Mm. Mm. I'm gonna have to do the same work here later. But I'm not gonna do it right now. With object tiles for tile index. All right, so this is the routine. I gotta add the palette loading in here. All right. And I think it's up here. I define a ROM data that has, yeah. On map place tile. Yep, okay. So based on the routine, there's going to be a load HLI here, right? Yep, load object tile. So, So the first thought that I had was to do the exact same thing I was doing one tile at a time. So for it's like for each tile on Game Boy Color, switch to color palette adjustment mode, write the palette, switch back to the regular mode to bank 0, and then write the tile. The thing I just realized here is I'd be doing that dance back and forth 4 times. So I'd really rather set the palette all in one big block. Yeah, that's definitely gonna be what I'm gonna want to do. Load object tile index into. All right, and then I'm doing anything with B here. No, I'm not. All right, so it looks like B is going to be a completely free register eventually. So, oh, this won't be so bad. Okay. All right, so I'm going to be loading this into, I think it was C, which I'm currently doing, but I'm going to add an extra byte for the palette index, and I'm going to load that into B. This isn't going to be that bad. I'm going to rename this to map tile data. That ruined everything. Why did it ruin everything? Okay. So this is changing from just this ROM data is going to change just from showing the index of the tile that we're loading to also give the palette of it. So let's define this. Mm-hmm. Okay. And then the triangle gem is 1. And then for giggles, let's throw 2 on these other palettes first, just so that we can know that this is working the way I want it to. So for right now, everything is going to start with 0, which is the blue palette. The triangle gem is going to load palette 1, which is the red palette that we've already defined. And then these other gems are just going to define palette 2 for now, which is still a gray palette. And then we're going to expand on this later as we go. All right. All right, so now we know the first byte is the Game Boy Color palette. So all right, so currently C has a tile index. But now the size of the structure has changed from 1 byte to 2. That's actually pretty easy to take care of. So the offset of the tile index. So let's say C equals offset of tile index, right? So right now C is just starting as a tile index. So C is starting, so right now C starts at like 0 points to 0 should be this, 1 should be this, 2 should be that, so on and so forth. We can't just add that to the base address anymore because now this is 2 bytes in size. When it was 1 byte in size, you could just add the index and it becomes the byte offset. Now, since the struct is 2 bytes in size, we now need to shift C left one, bit shift C left once in order to double it, and then the index becomes the offset. So C equals the offset of the tile index. HL plus equals the offset. And then C can't be larger than 127, so like doubling it isn't going to present an overflow problem. HL plus equals that offset. And then let's do B equals Game Boy Color palette. Not sure if this is faster or if this is faster. Let's see here. Load AHLI is 2 cycles. And then load BA is just 1 cycle, right? Yeah. Okay, so that's 1 cycle. Load BHL, that's 2 cycles. And then, okay. Increment HL is going to be 2 cycles. So we're going to do am I destroying A? No, this is fine. Okay. So B equals the Game Boy Color palette, and then C equals the index of the first graphics tile. And then right now, it should continue to work exactly the same way. So nothing should break. Is anything broken? No, nothing is broken. Okay. And it should continue to work exactly the same way on Game Boy as well. All right. Nothing broke because we weren't previously using B for anything. And now we're just storing the address of the Game Boy Color palette, but we're not doing anything with that yet. So right now, B is the address of the Game Boy Color palette. On Game Boy Color, write GBC palette to palette 4 tiles. All right, so A is not precious because I'm writing into it right there. So once again, load a GB model, and then we're going to test GB model. Okay. Yeah, GB. Yeah. All right. So on Game Boy Color. All right. So okay. So first, load a B because the first thing that we're doing is load palette index into A. And then DE is not precious because we're completely destroying it. So, but we are going to be messing with HL. So we're going to push HL and then pop HL. And then, well, we're going to want this, but this is the bit of code that actually does the copy. But first we need to switch into TileBank 1. So, actually, how am I doing on time? I'm a bit over an hour right now, so I think once this is done, I'm going to be able to draw the hero sprite, but I'm probably not going to be able to load him and start moving him around. Okay. Can I load? No. Man, this is annoying. Okay. Well, actually, can I load an N16? Okay, I can load an A into N16. Into a fixed address, and it is a fixed address, so we're gonna do this later. We're gonna do this down here. So, load A1, load CGB VRAM Bink select A. Do this copy. Switch to VRAM Bink 0. Is that everything I do? Is that everything I need? Is that gonna do it? Did I just finish the work? Did I just finish the work? I've sort of finished the work. That's interesting. Why'd this happen? That's weird, man. That's weird. That's real weird. Is it because I'm incrementing A? No? What? Yeah. I'm incrementing A. I shouldn't be doing that. Because right now A is a fixed palette value. We're not copying successive tiles of tile index data. Look at that. We're starting to get some actual Game Boy Color support going. All right. Okay, I think that'll do it for assembly code for now. Let's switch back to Game Boy and make sure Game Boy still works. Yeah, all right. And let's do some more palette data, but now we're just going to be coloring one object at a time. How's my map looking right now? What is an S10 file? From bank 0. From bank 0, which is 16 kilobytes. Currently has 15 kilobytes left. I'm using under 2 kilobytes. Cool. All right. Palette 2. It's going to be the diamond gem. I think that one's green. Set this to 3, 4, 5. See if that's 0. Let's have those share palette 6. Probably going to use a grayscale palette 7 for things like the X actually, but All right. All right. In fact, I'm gonna set the exit to palette 7 right now. Let's make the exit gray instead of blue. Yeah. All right. Okay. Let's create the green palette for the diamond shaped gem. All right. Right now, just all right. 0, 1, 2, 3, 4, 5, 6, 7. All right. So right now it's just going to be a red palette. So let's just see these turn red right now, and then we'll start setting the actual values in there. Cool. All right. So, all right. So the black value should be kind of a blue-green. So let's set 8 and 3. Probably not going to be able to actually visually tell that I did that, but oh, hey, the green palette doesn't actually use the dark shade. So I'm just going to have to make one up. I wonder if I can use that fact to... No, I don't think so. Just wonder if I can maybe use that fact to reuse the palette for another tile, but I don't think that's going to actually happen. So this is going to be the only one that actually matters. 26, 15, and 10. Let's do 26, 15. Again, trying to have a bit of a yellow lean of the green color. Hey, that's an interesting look. That's okay. I like it. All right, so I'm basically done there. Okay, and then the dark gray is going to be starting to shift towards, so we'll just swap those two colors around. And it's not going to appear visually because that color doesn't actually appear in the tile. But all right, next I think is the purple gem, the square gem. So again, let's just copy this palette over. The purple square gem. All right, and now it should look green because I just copied that palette over. Yep. Oh, the dark green isn't too bad. 4, 5, 6, 7. All right, all right. So purple color, purple, purple. This one's going to be a little bit unique to create for the hue shifting because this is already so close to like a purple or a blue because it is purple. So let's start by just defining a really vibrant purple for the highlight color. And then go way, way darker. Let's do like 12, 5, and 16. And then here, let's do an 8, 6, 3. See how this looks right now. That's not bad. The highlight color is too bright, but so let's actually just knock that down to 27 and 23. Actually, these colors all kind of clash quite a bit. This isn't actually that great, but I really don't like that the green gem is using so much white. But I think my hand might be a little bit forced on that just because of how I'm going to be working with sprites later. All right, let's get the yellow palette in there. Okay, so it's going to start as, let's look at that Game Boy Advance screenshot again, because yellow is not in that screenshot. um, Yellow is interesting. Um, because it looks weird if you start shifting it towards blue because you like go through green and that just doesn't really communicate like yellow to me. So it's like, as weird as it is, I prefer to shift yellow towards red as you're going towards the shadow colors. So I'm going to start with prominent yellow as the bright color. Oh boy, this is going to look terrible, isn't it? Yeah, that's just awful. All right, and I'm going to shift it a lot towards red and towards a reddish orange in the darker colors. So let's do 5, and then let's do 8, 6, 3. All right, it's too green. Why is it too green? Well, it's too green because it's literally too green. That's not so bad. Let's brighten it up a bit though. Let's use a little bit more red than that. So one of the things, does Saint Boy have color adjustment to mimic Game Boy Color colors? In fact, is it already doing that? Color correction, emulate hardware. Oh boy. What does it look like if I don't do that? Oh boy. Okay. Harsh reality. Okay. Emulate. Okay, so I'm actually already emulating Game Boy Color hardware, and this might be what it ends up looking like on a Game Boy Advance. Um, yeah, so one of the problems with the color systems, especially the first generation Game Boy Advance, was things like a really messed up gamma curve. And so a lot of colors can end up reproducing terribly on actual hardware. So that's going to be something I'm going to have to test a bit. For now, I want that to be even more orange. I kind of want to almost just steal the color from the red gem palette. What does it look like? 25 and 10? Right, because I was shifting it towards purple. All right, so 25, 10. Let's reduce that to 8. That's too much. Kind of want to introduce a little bit more red in the highlight color. Or maybe just take down the green just another tick. Okay. Okay. All right. That'll be fine for the yellow color right now. All right. And Star Gem. fact, what I think I'm going to do is I'm going to make the teleporter use the same palette that I'm going to use on the Star Gem. And I think it's going to be something that's going to be like a white, blue palette. It's going to be like the background palette, just like a more intense blue in the mid-tone. Let's grab the original terrain palette. Maybe they should just use the terrain palette. I kind of want the dark blue to be more intense, so and I know I want to keep 0, 1, 2, 3, 4, 5. So one of the things I know I want to keep going on the palettes is to have a room for just a regular grayscale palette that I could use for fonts or something. Just I want to make sure to keep a grayscale palette open. So in fact, I'm just going to force that right here. Palette 7 is grayscale. Okay, signing 7, yeah, using it for the exit, sure. Okay, so I've got the more intense blue there. What am I going to do about the highlight color, though? Maybe I should actually drag the highlight down a bit. I was thinking of making it be a brighter blue, but maybe I should actually make it be a slightly darker blue. But it's got to be more saturated than that. So actually, decreasing the amount of blue was probably a mistake. So I've got 25, 20, and 15. Or actually, there we go. Now it's more intense blue. There. All right, all right, all right. Still probably a waste of a palette slot to have just another shade of blue in there, but I think it's gonna work for my purposes. So now it's just the switch in palette 6. It's gonna be a variation of the red palette. This is just gonna be more brown. In fact, I'm probably gonna end up reusing this palette for the hero. That is colorful. It's probably quite a bit more color work that could go on to unify these palettes a bit and make them more harmonious. Okay. So highlight color, how are you making them more brown? I think you desaturate the colors to make them brown. So let's bring this down to 4, bring this up to 18, bring this up to 15. We're adjusting the highlight brown color right now. Yeah. 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 probably some more than I need to do on that, but all right. And then here we're gonna really crank down the color here to like 15, 12, 8. This is getting somewhere. There's a lot of work left to do here, but let's do 2, 6, 5, 4 actually might be right. Okay. How can I make this a little bit more orange? That up to 10? Okay. This is a very colorful looking game. We're at 1 hour 40 minutes. So I think we're probably going to wrap up here. And once again, still works just fine on Game Boy. Wow, that's green. It remains compatible on Game Boy, but on Game Boy Color, we now have colors. All right, that was a much bigger task than I thought, because I really thought I was going to be able to get to the hero sprite. Probably not worth it to do all the palette work purely in text. That was a pretty slow process, and the assembly code took longer than I thought. But there we go. So what did we do today? Well, we adjusted the barrier art there, and we made some Game Boy Color palettes. All right. I think I'm gonna go ahead and call that a stream. And I'm gonna pop this into my Game Boy Color and see how it looks. And I'll tweet out a photo of it. So, thank you very much for watching, and I will see you next time. Bye.